Hello and welcome to another video for Reigate Maths series on the Year 2 pure from the A-level maths content. This video is looking in the topic of trigonometry at modelling. So modelling comes in many shapes and sizes. Quite often in the real world, trigonometry is involved with modelling because it's a very nice way to describe something that is repeating, or a phenomenon that's repeating. So take this example for instance. The temperature of an oven can be modelled by the equation given there, where capital T is the temperature in degrees C, and X is the time in minutes after it first reaches the desired temperature. So if you think about when you turn your oven on, it gets the desired temperature, you put your food in. If you watch it, it doesn't stay at that temperature. Sometimes the light will come on to say which is not there yet, and sometimes the light will go off. The temperature of the oven will fluctuate slightly, so we're using this very simple model to talk about that. So we're going to first off state, so very little working required, the minimum temperature of the oven after it has reached the desired temperature. So we're using the model. So the minimum temperature is going to be, 225, that's not changing, that is a constant. Minus, but we know that this is the bit that is changing. So the 0.3 doesn't change, but what's the minimum value of this? Well, the minimum value of this is -1. So we have to be very careful because this has a minus here. So don't automatically think minimum temperature, minimum sign, -1. In fact, it's going to be when the trig bit is maximum that this whole thing is smallest, because then that gives us 1 here and we're subtracting it. So we get 224.7 degrees C. The maximum temperature will be when this is -1, it'll be 225.3 degrees C. So we can guess the desired temperature for this experiment, or for this particular model, is 225 degrees C. And we can see the temperature of that oven is going to fluctuate by plus or minus 3 degrees either side. So it's not too bad. So now we get on to our part B. Find the times during the first 10 minutes when the oven is at minimum temperature. So that you've got to be very careful with these modelling questions with trig as to what interval you're solving in. Times during the first 10 minutes. Times means there's going to be more than one answer. 10 minutes means that x, we're solving for x is between 0 and 10. And technically it's inclusive, but we know it's not going to be 0 or 10. Which means that we are solving for 2x minus 3 is between -3 and 17. So this is quite a big interval, so we can probably assume there's going to be at least 3 answers, maybe more than that. But beyond that, it's just a case of going, well, let's just solve an equation. We've already decided that it's at its minimum when sine of 2x minus 3 equals 1. Remember, we are solving in radians. So we just solved that. And now this is really useful to think about when is, or what is, pi equal to? How big is pi? Because pi is about 3. So let's go about solving this. So our principal value is going to be pi over 2. Okay, which means our secondary value is pi over 2. So let's think about a third one. Well, if we add 2 pi to this, we get 5 pi over 2, which is great. Pi is 3-ish, so 2.5 pi is 7.5-ish. Which is definitely less than 17. So this one fits. Let's keep going. So adding another 2 pi onto that, we get 9 pi over 2. Now 9 pi over 2, if you type it in your calculator, is about 14. So that's good. If we add another 2 pi to that, 2 pi is about 6. So if we add 6 to 14, we get 20, which is outside our interval here. But we have some negative answers. So we need to think about potentially going the other way. So minusing 2 pi from this, we get minus 3 pi over 2. Well, that's 1.5 times pi. So that's 1.5 times 3-ish. Now that's very much more negative than minus 3. So we in fact don't need to think about it for this example. But we might have to for other examples. So it's something to pay attention to. Once you're here, it's then a case of working each of them out. So we get 2.2854, 5.42699, and 8.5686. Now, because this is modelling, we need to relate it to the question. So we need to say times after minimum temperature, times at minimum temperature, are after 2.29 minutes, 5.43 minutes, and 8.57 minutes. Okay, so our last part of this example, calculate the time when the oven first reaches 225.2 degrees. So obviously we're solving this equation. 225.2 is equal to our model. Remember, we're solving for x is between 0 and 10 because we know that it hits the minimum temperature multiple times between 0 and 10. So, it's definitely going to be hitting the maximum or hitting this at some point for the first time. Very close to 0. Won't be close to 10 minutes at all. But that's something that we need to pay attention to. More specifically, the negative side of things. So we're solving sine 2x minus 3 is equal to minus 2/3. Okay. Rearranging, we end up with that. Okay, so this tells us that 2x minus 3 is minus 0.7297. Now this is fine, but don't forget we're adding 3 to it and then dividing by 2. So in a roundabout way we can think of we're adding 1.5 to this answer. Is that going to be the first time that it hits that temperature? Possibly, possibly not. But so what we need to think about is potentially the going further negative. So if we work out our secondary value, if we do 180 minus pi minus 0.7297, pi minus minus, so pi plus, we end up with 3.871. Now, this is obviously not going to be the right answer, so we're going to ignore that. But it allows us to work out a third value, another negative one, by subtracting 2 pi from this. We get minus 2.412. So now we can see if we add 3, so this one we're definitely going to ignore. If we add 3 to each of these, this is going to get closer to 0 than this one. If we add 3 to it, this becomes 2.3-ish, and this becomes 0.6-ish, which is much, much closer to 0. So this is the one that we're interested in. We don't care about that one at all. So we know 2x is 0.588135. So x is 0.294. Now, because this is minutes, we should probably convert that to seconds. We do that by timesing by 60. So 0.294 times 60 is after 17.6 seconds. So therefore, oven first reaches 225.2 degrees C after 17.6 seconds. Once it's reached 225, which is the desired temperature. If we wanted a different desired temperature, so say we were cooking something at 180, we could just change this to 180 and then do some questions around that. Okay, so that's how we can use this simplifying format to solve some modelling problems. Thank you for watching.